Good day to all electricians. This is Engineer Simeon Panusuela and welcome back to my channel. Our topic for today is the full voltage magnetic starter, wherein we are using current transformers connected on the main line, and then connected to the current transformers is the overload relay. In the ordinary magnetic starter, we can see that the overload relay is directly connected to line 1, line 2, and line 3. But in our topic today, there are two current transformers connected. One is on the line 1 and the other current transformer is connected to line 2. And on the secondary of the current transformer, the overload relay is connected to the secondary of the CT. The purpose of the current transformer is to reduce the current flowing to the overload relay. Just like on the kilowatt-hour meters with current transformer, the purpose is to reduce the current because the current capacity of the kilowatt-hour meter is small. So similarly, in this case, we can use small current rating of the overload relay because we are using the current transformer. So we have here the power circuit of the current transformer on the left side, and on the right side is the schematic diagram of the full voltage magnetic starter. We have here the molded case circuit breaker, magnetic contactor, and then connected on the line 1 is the current transformer, and on line 3 there is also another current transformer. There is no CT on line 2. The secondary terminal of the current transformer is labeled as small letter K and small letter L. This is a Japanese made current transformer. If we are going to use US made current transformer, this will be X1 and the other terminal will be X2. So here we can see that the secondary terminal letter K on the CT connected to line 1 is now connected to the heater of the overload relay for line 1. And the secondary terminal small letter L is connected on the load side of the heater on line 1 for line 1. Similarly, the small letter K on line 3 on the CT of line 3 is connected to the heater on line 3 of the overload relay. The small letter L on the secondary of the CT is connected on the load side of the heater. So here is the normally closed and the normally open contact of the overload relay which is connected to the control circuit. The meaning of CT ratio, for example, if the CT ratio is 100:5, that means that if 5 amperes is flowing on the CT secondary, then 100 amperes is flowing on the primary, which is the wire. In the current transformer, the branch circuit wire, this one, the color blue, is called the primary. And the secondary terminal is the letter K and letter L. So, if 5 amperes is flowing, for example, in this red wire, 5 amperes flowing going to the overload relay, that means that 100 amperes is flowing in the branch circuit wire. So that is the purpose of why we are using current transformer, to reduce the current flowing to the overload relay. For example, even if the current in the primary is 200 amperes and you are using 200:5 CT ratio, then only 5 amperes can flow into the overload relay. So now we are going to review the schematic diagram of the current of the full voltage magnetic starter. We have here the stop push button, start push button, holding circuit interlock, and the coil, letter M, of the magnetic contactor. So if you push the start button, the coil will be energized and the main contacts of the contactor will close, and the motor will run. The holding circuit interlock is a normally open contact of the magnetic contactor. So this normally open contact will close, and if you remove your finger from the start button, this will be open again. And since this is already closed, it will bypass the start push button, and the current will flow through here to the holding circuit interlock and then to the coil. And then this goes from the coil, it goes to the normally closed contact of the overload relay and back to line 2. So that is the wiring of the schematic diagram of the full voltage magnetic starter. In this third drawing, we still have two current transformers. One is on line 1, is the other CT is on line 3. But now we have two. Instead of the wire going through the hole of the current transformer, the wire is wrapped 2 times on the side of the current transformer. There, it is wrapped 2 times before going to the load side, to the motor. So now the current will be increased because it is wrapped 2 times. So the purpose of this scheme of using CT and then wrapping the branch circuit wire through the the whole of the city 2 times is to increase the current going to the overload relay. In this case, if the current to the motor is very small, you can wrap the branch circuit wire to the current transformer in order to increase the current that will reach the overload relay. So this is the purpose of using CT current transformer in the full voltage magnetic starter. If you have any comments, please comment on the comment section below. So this is all, and thank you for watching. Don't forget to like, to share, and to subscribe to my channel. To God be the glory.